A lot of what you talked about there, Jeff, is really take us into the area though of economic returns and carbon savings, etc.
Yes, yeah.
Can you perhaps just talk us through how EnergiVault can be used to unlock value? And I'm going to pull up another slide here for you.
Yeah, okay. I mean, what we've found talking to a lot of potential clients is, carbon savings actually one of the main drivers, but obviously energy saving and cost saving, particularly over the recent past with energy costs being so high, is not surprisingly equally important. Just to sort of explain a little bit about where CO2 savings come from. One of the main applications for EnergiVault is the optimization of existing chillers. So, chillers when they're on part load are generally not as efficient, not operating as efficiently as they are on full load. And depending on how you set the controls up, effectively you can avoid that, depending on how many chillers there are and whether they're cascaded or whatever. So you can effectively reduce or replace that inefficient chiller capacity. And we found, chillers in sort of February, March time running at, with a COP much less than 2. If you can replace that with stored energy, which has been created with a COP over 3, then you're effectively roughly 50% more efficient, delivering EnergiVault instead of that part loaded chiller. If you're 50% using 50% less energy, then correspondingly you're using less carbon, and depending on where you're taking your power from, whether it be local on-site generation or mains grid, again you'll probably reduce your CO2 by at least 50% when you're replacing that chiller load. So there is a period of time when you're optimizing chillers that you're effectively reducing your CO2 by improving the efficiency of the energy which you're producing. One of the other big benefits of EnergiVault is that if a site has on-site renewables, in particular, PV on the factory roof or whatever, or a small wind turbine, but not only is it less cost effective if you're exporting that on-site generation, but obviously if you're able to optimize and use that energy to store energy in an EnergiVault, then effectively you're maximizing your zero carbon energy, and thereby obviously delivering quite a significant saving. And what we're finding is that customers that may have had excess PV and not seeing all the benefit of that PV because they're exporting some of it, you can ensure that more, if not all, of that on-site power is then absorbed into the EnergiVault battery. So again, that's another element of where CO2 savings can come from. Most people perhaps are aware that the carbon intensity on the grid varies between the night and day, not as much as it used to. It used to be quite a significant variation, but there is still variations in the grid carbon intensity. And again, depending on the time and duration of charging the EnergiVault, if you're discharging it at a particularly high carbon intensity period, which is typically between sort of 4 and 7 o'clock in the day, when the marginal plant is coming on and the carbon intensity gets greater, then again, there's another area where you're saving carbon. So there's several areas in which you can demonstrate carbon emission saving. From a sort of more conventional savings, pounds, shillings and pence, obviously an energy store allows you to load shift. And depending on, again, there's so many variables in this, depending on customers' situations. But if you're a customer with a day-night rate, let's say, on your electricity, and then by charging during the night and shifting that expensive daytime energy with nighttime energy or off-peak energy, then clearly you're able to demonstrate a saving. Also, you can optimize that saving by minimizing not only or avoiding the high tariff energy, but also avoiding the high GEOS costs, which are the distribution charges, which are typically charged between 4 and 7 o'clock. So load shifting is clearly a large area of value. In addition to that, in fact, more and more prevalent these days is the demand response value that can be obtained from National Grid ESO, often via an aggregator. But actually last winter, there was a new system introduced. In fact, some people on the call may be familiar with it because it was actually targeted initially at consumers. It's called the Demand Flexibility Service. And that basically paid consumers £3 a kilowatt hour for shifting energy from those peak periods, and did that by a day ahead, informing the customer of an event, which may have been an hour or 2 hours. Typically, it was between 4 o'clock and 7 o'clock, often between 5 and 6. And if you take an example of the system we have at Quotient, that 1 megawatt hour, if it was discharged in those 22 periods during the winter that were part of the demand response program, then that would have created £26,000 worth of value. So demand response is becoming an ever more valuable element. So in other words, you could say that's in front of the meter value, network value that you could gain from energy storage, in addition to the behind the meter value, such as the shifting of the optimizing of chillers, which not only is carbon efficient, obviously is energy efficient, pounds efficient, and the baseline, the time of use shifting elements.